my earlier video, I covered direct variation. Today, I'm going to cover inverse variation. I will do a simple warm-up question and then go on to some word problems involving inverse variation. In real-world terms, inverse variation is when something increases, something else decreases. For example, the longer you drive, the less fuel you'll have. That's an inverse variation. So we always look out for the keywords when we're solving problems. Here, y varies inversely, that's our keyword, as x. Y is equal 5 when x equals 10. Determine the inverse variation equation, then determine y when x equals 8. So we can write it as y equals, now it's an inverse variation, so we can say it's k over x, with k being your constant of proportionality. This is the steps you want to take. First, write your general inverse variation equation, and then what they often do is they'll give you your y and x in one case, and then you have to find your k. And then after you found your k, you're supposed to find your y or x given new values. So we're going to plug our given values. When y is 5, we don't know our k, but we know our x is 10. Multiply both sides by 10, we get k 5 times 10, which gives me 50. So therefore, we can write our equation as y equals, now k is 50, so we have 50 over x. Now we need to find our y when x is 8. So we can say that y 50, now our x is now 8 from here, over 8, which equals 6.25. And your inverse variation equation would be y equals 50 over x. Let's try a simple word problem. The length of a string varies inversely, that's our keyword here, with the frequency of its vibrations. If an 11-inch string has a frequency of 440 cycles per second, find the frequency of a 6-inch string. So we need to set it up. We're going to talk about length. Let L length and F be frequency. So I'm going to write my equation as L equals, it's an inverse variation, so it's going to be k per our f. Now we're given the inverse variation in the first case. It's an 11-inch string, so our L is 11. And what we want to find is our k. So we don't know what k is, but we know our f is 440. So therefore our k equals 440 times 11, which results in the number 4840. That's our constant of proportionality. Remember, we always have to find our constant of proportionality before we can plug it back into our original equation to find the unknown in the question. So now we have our constant of proportionality, so we can write it as L equals, our k is now 4840 over our f. And now we want to solve for f when our L is 6. So we're going to change our L to 6. 4840 over f. Cross multiply, we bring the f up and we bring the 6 down. So we get f equals 4840 over 6, which gives us 8.06.67 cycles per second. This one is more tricky. The force F needed to break the board varies inversely with the area A of a square board. If it takes 24 pounds of pressure to break a square board 2 feet long, how many pounds of pressure would it take to break a square board that's 5 feet long? So be careful here because you are given length, but we're talking about inverse variation with areas. So I'm going to say let F equals our force and L equals the length of our board. So F equals our K, which we don't know, over A, which is what's given. It varies inversely with the area of A. But we're given L. But we also know it's a square board. So we can say that it is also equal to K over L squared, because length times length in a square gives you the area. Let's plug in our given values. We have 24 pounds of pressure, so our F is 24 equals, now we don't know what our K is, so I'm going to leave it as K over your L, which is 2 feet long. So we're going to do squared because length times length gives us our area. Simplify, so I have 24 equals our K over 2 squared, which is 4. Multiply both sides by 4, I get K equals 24 times 4. That gives me 96. Now we've found k, we can plug it back into our equation of f equals k over a. So now our f is what we want to find, equals 96 over, now we're not given the area of the new square board, we're given the length, so we have to do 5 squared, which simplifies to 96, 5, which equals 3.84 pounds of pressure. Before I end the tutorial, I wanted to give you another example very similar to the first one, but now involving fractions. So y varies inversely, that's our keyword, as x. Y equals 2 when x equals 1/5. Determine the inverse variation equation, then determine y when x equals 16. Method is still the same. Do not freeze when we see fractions like so. So we're going to say that y equals our k over x just like before. Plug in our known variables. Y is 2. We don't know what our k is, but we're given x is 1 over 5. So we want to solve for k, so we have to get rid of our 1 over 5 by multiplying both sides by 1 over 5. Don't freeze with the fractions. It's the same method. So we have k equals times 1 over 5, which gives me 2 over 5, or 0.4 if you prefer to work in decimals. We know what our k is. Let's plug it back into our y equals k over x. We want to find y when x equals 16. We can say that y equals k, which is 2 over 5, over 16, which is our new x. So that's the same as y equals 2 over 5 divided by 16. With fractions and dividing, we can write it as 2 over 5 times 16. These two are divisible by 2, so you can reduce 2 divided by 2 is 1, 16 divided by 2 is 8, and that gives me 1 over 40, which gives me 0.025, and we can write our inverse variation equation as y equals, our k is 0.4 as we found, over our x, and that would be our inverse variation equation. If you like this video, please be sure to like and subscribe to my channel. Hit the bell button for notifications. I offer online tutoring services as well as notes, lessons, worksheets with full answer keys for sale. Links below. I have a Patreon account if you'd like to support me that way as well. Thank you for joining me, and I hope you found this session helpful.